Okay, so here are our notes for today, kind of refreshing our memory on factoring. So we're still in the midst of chapter 4, even though we took that test before break, just kind of finishing a couple things up. So the next couple of days will be graphing, and then we'll talk about inequalities and writing equations. So the fun never ends with quadratics, but we're first going to refresh our memory on how we factor, because we're going to be doing that with pretty much all of the things that I just mentioned that we still have yet to do. So just a couple of reminders. First of all, know that we will sometimes have to use divide and slide. And remember that we use divide and slide whenever our A is not equal to 1. And when I say A, I mean, hey, if you've got something that's ax squared plus bx plus c. So if that leading number in front of your x squared is not a 1, and it is not a GCF either, so you cannot just take it out, you will have to use divide and slide. So always start by taking out the GCF, right? If you can, you should. And then beyond that, you multiply your A and your C. And again, I mean the A in front and your C being your constant term. I ignore the signs, whether it's a plus C or a minus C, whatever. I ignore those until the end, but so just the positive numbers, whatever. And then you look for numbers that multiply to that, whatever you got, AC, and whose sum or difference is B. So do they add to B or do they subtract to B? We'll talk about the difference. You set up your parentheses. You always start by putting your variable first. And you will say, oh, okay, these would be my numbers. My signs are the same or different, whatever. And so it's going to look something like this. Then what you do is you divide your numbers by A. If it reduces to get a whole number, perfect, you're done. But if it doesn't reduce to give you a whole number, you end up sliding whatever that denominator was in front of your x, still inside your parentheses though. That's important. Now, a couple other things to keep in mind. We have some patterns. Our dots pattern, dot stands for difference of two squares. So difference means subtraction. So you need to have two things that are both perfect squared and they're being subtracted from one another. What we do is we set up our two parentheses. They become 1 plus 1 minus. Whatever term is the square root of your first term is going to go first. And whatever term is the square root of the second term is going to be written second. Our other pattern is our perfect square trinomial pattern. And so that one always started and ended with two perfect squares. But it's a trinomial. Tri means 3. So we've got this middle term, which is 2ab. Not the end of the world that we notice that, but that's what it technically is. But it's always going to start and end with two perfect squares. And this time around, your sign in front of your last perfect square is going to be a plus. When we factor that, this just becomes one set of parentheses squared. And it's still, square root the first term, that goes first. Square root the last term, that goes last, B. And then we have to figure out what our sign is, and it's going to be whatever guy was right there. So if it was a plus, it's going to be a plus. If it was a minus, it's going to be a minus. So be on the lookout for using those patterns. The perfect square trinomial is important to note. We use it mostly for completing the square because you can technically set those up just by using two normal sets of parentheses and using divide and slide if you have to, like normal. But be on the lookout for those. Okay, so moving right along to our first examples. So example 1, we want to factor 5x squared minus 35x minus 40. Well, as always, the first thing we do is look for a greatest common factor. We look for something that we can take out of everything. And in fact, all 3 of our terms are divisible by 5. So what we do is we divide everything by 5. We don't get to throw it out the window. We just set it aside. Well, 5x squared divided by 5 is just x squared. Minus 35x divided by 5 is just going to be 7x. Minus 40 divided by 5 is 8. So now the real thing that I'm actually factoring is just that x squared minus 7x minus 8. We have to bring that 5 along with, but we won't have to divide and slide because our new term in front of our x squared is just a 1, which is great. So we set up our two sets of parentheses. We look for numbers that multiply to 8 and subtract to 7 because of that minus sign before our very last thing. So numbers that multiply to 8 and subtract to 7, 8 and 1. Our signs are different, again, because of that same subtraction sign. And our bigger number, the 8, is going to be subtracted. So x minus 8, x plus 1, and we're done. We are not asked to solve, we are just asked to factor. So we stop when we get to our final parentheses. Example 2 is similar-ish, but we cannot take a GCF out of everything. So this is when we'll use divide and slide. Well, I don't have a GCF, so that's step 1 of divide and slide. Step 2, you multiply A and C. So 8 times 35, again, ignore the negative in front of the 35. 8 times 35, we get 280. So we are going to be looking for numbers that multiply to 280 and subtract to give us 6. Just by plug and chug, start dividing, look to see what numbers multiply to give us 280, we're going to find that it's 14 and 20. So we set up parentheses, x and 14, x and 20. My signs are different. My bigger number is negative again, so minus 20 and plus 14. This is when we do divide and slide. So we divide and slide by that leading coefficient of 8. And both of these are going to be able to reduce, but not down to a whole number, which is fine. 14 over 8, take 2 out of top and bottom to get 7 over 4. That 4 is going to be what's going to slide in front of that x. You always slide the denominator. So we have 4x plus 7. And then over here, 20 over 8, we are able to take 4 out of top and bottom this time. So we get 5 over 2, slide the 2. 2x minus 5. And there we have our final answer. We can always check it, by the way, by foiling it back out. So be prepared to do that at some point in time.